Great. Thank you very much, Sarah, and everybody. Thank you for inviting me. So very pleased to be able to step in. Let me just share my slides as well at the same time. Hopefully you can see those. Yeah, so my name's Gareth Morgan. I'm the founder and CEO of Terrabotics, and I'd like to share with you a bit of new innovations that are happening with the world of satellite remote sensing technologies and Earth observation technologies that hopefully you will see the value and possibilities that they are and will create for mapping, measuring and monitoring risks on a global to local scale.
Awesome. So Gareth, I hear that there's been quite a lot of development in the world of satellites over the last little while. Would that be correct?
Yes, that's an understatement, which hopefully I'll be able to show. I've got lots of nice pictures and slides because I can't talk about satellite imaging and sensing without sharing some nice visuals. So hopefully they'll be able to convey that. Here we go. So to answer your question, as you can see from this slide, this is showing the huge scale of sudden rapid development of the world of satellite sensing possibilities. So draw your attention to this sort of watershed moment around 2014, where we suddenly went from sort of decades of science, government-funded satellite projects to suddenly a new commercial era where we've had an explosion, literally in some cases. They don't always make it into space successfully, but a huge amount of satellites have been launched in the last few years that very few people will be aware of, and there's a big commercial era of space. Of course, you hear about SpaceX, etc., but a lot of these missions are taking satellites 300 at a time, sometimes in a single launch. And so these are just some of the numbers of the successful launches per year. You add all of those up and these satellites are operational together. So we've gone from having a handful of satellites a decade ago to use to suddenly hundreds of them. So at Terrabotics, we use data from up to 300 satellites every day, every week. So there's a huge revolution of data. And this just to give you a feel and a flavor of the sort of level of data we're getting on a daily, weekly basis. So our specialism at Terrabotics is to look at natural resources sectors, mining, oil and gas, energy, renewables, water, forestry even. And so you're in a position now where every day, every week, every month, every quarter, you can start to keep an eye on these assets and watch risks evolve before your eyes, from social, environmental risks associated with assets that would otherwise potentially be in remote, far-flung corners of the Earth.
So Gareth, all of this is optical imagery, is that correct? Is that all we get from satellites, or do you get different types of sensors, different types of data being collected?
Yeah, that's a very good point. I think you're probably preempting what I'm about to show next. So this is sort of hundreds of essentially floating digital cameras, right? Sensor cameras taking nice pictures, but huge volume of data every day. But it's more than that. It's much more than that. This is why the title is remote sensing. So we're not just talking about observations and images. We're talking about exotic sensors, from thermal imaging, gas emission sensing, laser ranging, even radar sensing capabilities that can image through clouds day and night, and hyperspectral imaging that sees beyond the visible spectrum. And so this opens up a huge world of possibilities to map, monitor, measure what's going on the Earth's surface around the world. And we're just starting to sort of scratch the surface of this. A lot of these satellites, like I show here, have just been launched in the last 2 years. And we expect many, many more of them, constellations of these, to be launched over the coming months and years. So this gives us a huge deluge of data, petabytes of data per year per satellite, huge amount to deal with. So we have all of this opportunity created now, but we have a data deluge to deal with.
And so how do you deal with all of that data?
So that's the key. We have this data deluge, and so now the opportunity is created by that, but now we've created a problem for ourselves. We have to deal with this data and deal with it at scale. So that's what Terrabotics exists to do, is to make sense of this data at scale and create real value for real focused purposes. driven by user needs and demands. So we have the data, the raw data from satellites. You can throw drones and even ground sensors into there. So you've got all of this sensor network, this data coming on at least a daily basis. You've got to be able to deal with that at scale. And this is beyond the human analyst to be able to study an image or something that might have been the way before. But this opens up huge possibilities to do a lot more as well. So AI is a huge vital ingredient in here. Cloud, distributed high performance computing, graphics card computing. This really describes a convergence of key technologies that enable us to create value from this data. So you need the ability to scale, you need the analytics, the pattern matching, the AI, the strengths of AI to do the heavy lifting. You need the computing to power it.
Sorry, on you go.
I was just going to say, then, but there's nothing unless you have the expert insights, the expert knowledge to actually focus it on something. That's why we're sector vertical specific, but everything I talk about can be applied to insurance, to post-disaster, pre-disaster planning, mapping risk, to crop measurement management, and to natural resources. So if you can bring in that expert domain knowledge as well to make this purpose-driven and bring the users into the loop so that you create something of value to them, that it turns this into all this exotic data and imagery into clear metrics and something that's actually actionable and useful.
So Gareth, I'm going to ask you if you've got like almost an example or a case study of, say, where you're using artificial intelligence on some of these data sets. But just quickly before you go there, Clive Thompson's just put a great question into chat, and he asks, so we've got all of this data coming from satellites. Who owns the data? How do you get hold of it? How do you see it? How does all of that work?
Yeah, great question. So if you see that things that graph I showed, it actually showed two areas. So in the past, it used to be government satellites built by government, for government, by government contractors. The beauty there is all that data is freely available, openly available from the European Space Agency, NASA. It's free at source. This is hugely enabling policy, basically, policy combined with technology to enable huge applications. Terrabotics would not exist, and companies like us would probably not exist and be able to do the things at the scale we can do them without that public data sets that are there. The challenge is to do something with this exotic data and have the knowledge and expertise and the technological expertise to translate it into something useful. Then there's commercial data and there's commercial companies, and we're at a stage where there's now commercially funded satellites launched by commercial companies, still mainly supplying governments, but also supplying us. And there will be in the future commercially funded satellites funded by commercial money, delivering just commercial products to commercial companies. And so we're on this journey, and that's increasingly happening, and we're here to encourage that and make this happen. So basically, anyone can access the data, anyone can purchase it, and that's a key thing to think of. If you're a company, an industry doing something in some remote part of the world, there's essentially nowhere to hide from this data. It's available to news agencies, NGOs, IGOs, small companies, big companies, yourself to do things with. So
what I guess you've got there is you've got full transparency, but the key is, okay, yes, you could go and download a load of this data, but actually it does take some skill to be able to not only look after the data, but also analyze it and turn it into something useful. Would that be correct to say?
Yeah, let me give you an example. I've got a little case study I can share, which I think covers all of these points. So this is a really nice case study of all of this in action. You're probably all familiar with this infamous tailings dams failures that have happened over the last few years, particularly in places like Brumadinho in Brazil, these wastewater and dams from mining operations that have failed and burst. So, huge risk case study. So where we have been involved in such activities is from an angle of the investors into the mining sectors, who have taken activist action to put pressure on the commercially listed mining companies to report on the risk they're carrying with these tailings dams, and simply ask them questions like, do you have tailings facilities? Where are they? How close are they to communities, populations, natural environment areas? And to report this back to their investors. And this is quite a successful initial initiative, just early days, I think, of this type of action. But driven by the Council on Ethics of Swedish National Pension Funds and Church of England Pensions Board, so big investors actually into the mining sector. And we were involved in a project to basically verify these disclosures. These over 100 companies in the end were asked to disclose key parameters about their tailings facilities. So they disclose them as thousands of disclosures of these locations around the world. But how do we verify these? So we can trust what's delivered to us, but let's verify as well. So this is a perfect scenario for freely and abundantly available satellite data that's available weekly, monthly, quarterly, continuously, with archives going back a few years and continuing into the future, plus AI to do the heavy lifting. So at Terrabotics, we trained an AI to identify tailings facilities in mines, a huge library of images of tailings facilities, and based on our knowledge of mine sites and their structure, to first verify the locations that were disclosed. And often we would find, actually not too surprising, that the locations were either incorrect or not that correct. So, and location matters. Like if you're giving the location of a great big body of water that could fail and flow out water and waste somewhere, it matters where that's coming from, and that will control where it's going to go. So sometimes the report might have given the mine HQ or the gates or something. We want to have the exact location for modeling and risk modeling processes later. So we can verify and correct those disclosures using satellite data, but also find all the undisclosed, which far outweighs actually the ones disclosed, all the undisclosed tailing facilities. As we found, it doesn't seem to matter what geography, Canada, Zambia, anywhere, plenty of undisclosed ones. So our AI does the heavy lifting. A human could not do this, trawl through the global satellite data in the space of hours, and can be done weekly if desired and kept up to date. So just to dive a bit deeper on that, that's a global catalogue viewing the and mapping essentially these sort of risks of tailings facilities that we know they all pose a potential risk. And so this is an extract from one of the disclosures for one particular mine. And one of the questions was, has there been a risk assessment of things like flooding risk? And the answer was yes, in 2005. So, well, that's a long time ago. And we can actually, with the power of satellite data, actually go back and interrogate this further. So from the data, the data archive, we can go back in time and see how the site has evolved. We can actually go back 20, 30 years if we have to with satellite data. And we have done for this particular site, and turning the sort of data into something a bit more actionable and useful. Here we're mapping the community and showing how it expanded from 2004, just before that risk assessment was done, then the red 2011, and then the purple outline is 2019. So this is nearest informal community to this mine site and its tailings facility. So we can see it's much more than trebled in size in that time. So it should be obvious to everyone that any risk assessment done through that period needs to be updated continuously. And the tailings facilities themselves have changed as well, or adapted. So what this data gives us is a chance to create dynamic data-driven risk assessments and map it and keep mapping it, i.e. monitor it and do that continuously and automatically, to some degree, allow the AI to do that heavy lifting. So we can have monthly updates, weekly updates if we so wish, even daily updates.
So with this, Gareth, I mean, I know that we've got one of our speakers later on is going to be talking about carbon. I noticed earlier on you mentioned that we've got satellites that can detect emissions. And I think that there are lots of people in as attendees on this session who are thinking about climate change. I know Jane has asked us a question about climate change and thinking about how do you do your carbon disclosure and everything. Can we use satellites and the data being collected by satellites to help us with all of this? Is the data robust enough to help us do that?
Yeah, so as I mentioned on one of those previous slides, I mentioned the mission satellite, and there's a new era coming of emission satellites. There's a few launched already. So we're in the early days of these delivering data and putting them to work. But we're expecting within the next couple of years, sort of 2030, satellites that can measure methane coming off sites, carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide, all of these potential gases of interest, particularly of industrial and agricultural emissions. So we're already putting some of that to work, also using thermal images to pick up gas flaring, natural gas flaring around the world in sites, so we can start to measure that directly. And the beauty of that is we have an observed objective data set that we can compare to disclosures. And you have companies themselves, oil and gas companies, who are having to model and create engineering assumptions about their emissions. So they want measurement techniques, they want direct objective measurement techniques to complement their assumptions so they can report correctly. So there's a huge demand for that we see, plus the investors, the regulators, policymakers wanting to scrutinize. So our mission at Terrabotics, our vision is to create transparency for all through the data, and hope that results in more responsible and sustainable natural resources production.
Brilliant. That's fantastic, Gareth. So, I mean, I think with this, and I can see again, there are more questions coming in, etc., in the chat and what have you. Do you have any final comments to make just in terms of where you see technology evolving, or is there something that we're missing at the moment that would actually help risk managers such as myself be able to make better decisions, or even better than that, actually instigate actions and change so that we can proactively manage our risks? Do you see anything else coming down the pipeline? You've already mentioned emission satellites, which sound pretty cool. Is there anything else?
Just lots of data, huge amount of data, but the data is just the first step of the problem. Like, it's no good just sort of drowning us in this raw data. We have to make sense of it. We have to have a kind of two-way. Nobody wakes up thinking I need a satellite image or satellite sensing data or some exotic laser ranger from space to manage my risks. So we have to educate people. We have to show them the art of the possible. We have to boil it into clear metrics. And so there's a lot of work together to do with the user community, technologists, product development companies like ourselves to do this. I'll just quickly finish on a couple of things to skip ahead to make a couple of points. While I'm doing it, a little video is going to run, which is showing flaring activity per oil and gas company measured from space. So we can sort of tie it to the specific asset, which relates to the question on emissions. But this is key. It's really about transforming raw satellite data into user-driven insights and actions. And so what is the outcome? You get dumped with a load of images? No, you have to create some metrics that are meaningful, either industry standard ones or ones that are evolving, or try and establish new standards of metrics with this new data sources. So there will need to be new metrics that work with the data that should create value. You can't necessarily shoehorn this new data into the old metrics. That's key. So, what do you get as the end user? These are sort of reports. It's things that are created from the satellite inputs, but it's human readable, understandable, actionable insights and reports.
Brilliant.
And to sum that up in 4 key points, it's the raw data, the AI, etc., helps you do that at scale. You need to guide that with expert insights, and then you get, and with your user community, get your user focus, actionable value.
Brilliant. Absolutely fantastic, Gareth. Thank you so much for sharing that with us, because I think that we've been talking about artificial intelligence, we've been talking about trying to make sense of lots of data, and here you've given us a really tangible array of case studies and examples where you're actually doing it. So I'm going to invite everybody to please put their hands together and say a massive thank you to Dr. Gareth Morgan and Terrabotics. Thank you very much. Brilliant. Thank you, Gareth.
Thank you.
Great. We're going to move swiftly on to